Hello and welcome. In this video I want to give you a neat hint which makes you able to add motion detection and automatic recording based on motion detection to pretty much every camera that has a streaming option, like an RTSP or HTTP URL, which enables you to watch streams coming from the camera. So if you are interested, keep watching. You might want to ask, what's the point of this video? I mean, if you take a look on the market, there are security cameras out there, great ones with movement detection already added and stuff like that. Also there are cheap ones which still have motion detection. So you might say, I can just buy one. Okay, but here's a fact. Motion detection in security cameras, I mean in most security cameras, especially in the cheap ones, is just, well, a lackluster implementation. I mean, when it comes to motion detection, the camera basically works on the data it can get out of the images. I won't get into the details and the science behind image processing and stuff like that, but believe me, there are plenty of research out there, and yeah, image-based movement detection is, well, still problematic. So the sophisticated and more expensive cameras apply sensors and whatnot to have a proper way of detecting movement. And this is basically what we will do here. So let me show you the schematics for this whole idea. So what we are talking about here is basically enhancing a camera, like almost any camera, with proper motion detection and motion detection based image recording or video recording. So what you can see here is that basically we added one more sensor in a separate location, a PIR sensor, which is, well, basically a movement sensor. And the technology is pretty much mature and it just works. So what we do here is use the PIR sensor to detect the motion instead of the camera's motion detection. Okay, now I have to stop for a second and explain something else. So what's the problem with motion detection based on images, and why do we need a PIR sensor? Well, the main difference is that how they work. The image-based motion detection works on trying to figure out what changed in the image compared to the previous one, and this is just done in an iteration. So camera takes a picture, some difference is calculated to the relative to the previous one, then the next picture and the next picture, and so on. So basically a series of images compared to each other, and if there's a difference large enough to trigger logic which says, well, it's possibly motion, then the camera is starting to record. While this sounds good in theory, imagine the situation when you have a room with large windows, and outside the windows something like a tree, which will cast nice and big shadows. While the sun moves around, or actually the earth turns, but whatever, then the shadows will change. And if shadows are in the camera's field of view, then they will change the image, which ultimately will trigger false alarms. Like you will get, let's say, notifications or something like that, because the camera thinks it's movement, but it's actually not movement, it's just the shadows in the room change. So yeah, that's a problem. Why the PIR sensor is totally different. Basically it's a way to detect the human body heat. So it works quite reliably. And with this setup, we can set the PIR sensor to a different location. So maybe you can have a hallway which leads to a room, and you can set the PIR sensor in the hallway, hidden somewhere, and the camera inside the room. So by the time the, let's say, burglar or something like that, or somebody like that, enters the room, the camera already started recording. But that's just an idea. Okay, so how does this work? Basically, we set up the PIR sensor together with, let's say, a microcontroller, which can communicate via Wi-Fi. And via Wi-Fi, it will send a message to something we call a message broker, or MQTT broker. MQTT is a protocol for communication between smart devices. If you're not familiar with MQTT yet, you might want to stop here and take a look around for videos on YouTube. Also, I had an earlier video related to movement sensors, especially ones using PIR sensor and MQTT messages and whatnot. So you might want to check that one too. Anyway, point is, when the MQTT message is sent, the broker will know who needs to know about this message. We call this the routing of the message. So let's say some other small computer like a Raspberry Pi or anything that is Linux based can just get this message, and when the message arrives, it knows that it has to start recording. Now in this case, recording will be pretty simple. We just grab the stream, the video stream from the camera, and save it to a file. And with that file we can do pretty much anything. Upload it into a cloud or an NAS, FTP, send it via email or whatnot. Or we can just keep it there on the agent, let's say hidden somewhere in the building or something like that. So this is basically the general idea. Now let me show you some more technical details and let's see how this works out in the practice. So in this video I will do the following. I will use a single Linux based virtual machine, but you can use a Raspberry Pi or pretty much anything that can run Linux. And I will install 3 components: FFmpeg, which will do the video recording, Mosquito, which is our MQTT broker. Now in this case, MQTT broker and the agent machine I've mentioned will be the same machine. It's like the cheapest solution. And the third component I'm installing is something called Mosquito client, which is, will be used for getting the messages from the broker. So let's install those. Next, what I will do is to show you how to use FFmpeg to record stream. So the URL I'm using here is just coming from my Octopi, which is basically a web camera connected to a Raspberry Pi on my 3D printer. So it provides streaming. But in case of a real camera, like an IP camera, you will have a URL here, which will consist of an IP address and some postfix which is unique to the camera model. Here's a suggested video which shows you the use case for such a camera. Anyway, assuming that you have the RTSP or HTTP URL from which you can record the stream, recording the stream with FFmpeg is pretty easy. So what does this command do? Basically it's just instruct FFmpeg to record whatever comes from that stream and copy it into a file. That's why A codec and V codec, which means audio and video, just parameterized as copy. And also there's an additional parameter which says we want to record for 10 seconds. And the URL of course, and the file name which will contain the stream we have just recorded. Okay, cool. So this works, but how will we just trigger it via MQTT? Well, do you see this little script I wrote? It's quite simple. What this does is just waits for a message to arrive, and when the message arrives it will just trigger recording. Now this is like very minimalistic. I mean, the URL is hard-coded, you cannot parameterize the script and whatnot, but the point is we can do something more sophisticated, of course, but I wanted to really show how it works with a minimal example. Also, it's worth noting that in the last line there's a part starting with -t hello. Now it means the topic name is hello. Topic is something related to MQTT. Basically it's like a channel where the message will arrive. Whatever you specify as a topic name will have to be used by the sender side, I mean the microcontroller that is connected to the PIR sensor. This will of course mean we will have to take a look on some Arduino code, but we will get back to that later. So the script is pretty simple again. It will wait for any message in the hello topic, and when that arrives, it will just trigger a 10-second recording. Well, we will get back to the script a bit later on. Let's see the Arduino code for a second. So as you will see, this is also a pretty minimalistic example. It can be uploaded to any Wi-Fi capable Arduino-like board, like a D1 Mini or something like that, or Node MCU, and it will connect to Wi-Fi, and it will wait for a signal on D2 pin, but of course that can be changed. So it will wait for a signal from the PIR sensor, and when the signal is received, then it will just send an MQTT message. This is the message that will be picked up by the script I just shown, and it will trigger the video recording. Okay, so we have a script, we have Arduino code, we need installation in Linux, and whatever. It's just getting complicated, right? Yeah, I guess so. So my idea is that we can simplify this a bit and also enhance its functionality, because right now the script works with hard-coded values, which is not nice. So let's see what I've done here. So I turned this script into Docker container, which will have most of the needed installable stuff like FFmpeg and whatnot. Also enhance the script a bit. So let's see it. The most important thing is that now the values are not hard-coded. Instead, I have turned them into environment variables, which will be filled up by Docker configuration, namely DockerCompose. Also added some error checking and whatnot to make it a bit more professional looking. Next up is the sample Docker file I have created. This will basically build the image we need to have this whole stuff running in Docker. As you can see, it has those commands for installation. It installs FFmpeg and the MQTT client. It doesn't install a broker though. You will need a separate container for that. Now that we have our Docker image set up and it can be run as a container, we will need a place where we can define those environment variables and some other configuration. And this is where DockerCompose comes into the picture. So here's the DockerCompose file. As you can see, the settings are there. If you download this code, you will need to change it to your own liking. One important thing is that I'm using a Docker volume for storing the recorded videos. To some people this might not be the best solution, so you might want to fiddle with the settings here, like instead of a Docker volume, using a local folder or something like that. To be honest, I want to keep this video as short as possible, so I'm not going into details of all the settings. I just wanted to present a general idea, so sorry if some of these things left you confused. Obviously, if you have any questions, then I'm ready to answer them in the comments. Okay, after all this hassle, let's see the whole thing in action. So right now I'm firing up the Docker container, then I will trigger the motion sensor. And yeah, it should start FFmpeg to record the video, and after 10 seconds it should finish with recording, and we will see the file there. Okay, so let's sum things up. Basically, with a simple idea and some hacking and with some Linux magic, we have just added motion detection and motion-based recording to a basic crappy old webcam which didn't have these features, and yeah, we didn't even had to touch the hardware, so let's say we didn't void any warranty or something like that. Pretty cool, huh? So if you like this video, then just consider subscribing to the channel. Anyway, thanks for watching it and hope to see you next time. Hey, thanks for watching this video. If you liked it, hit like. If you want to help my channel and see more of my content, hit subscribe. If you want to check out behind the scenes and want to know more about me, then follow me on social media. You can find the links here. Thank you again, and see you next time.